All right. Welcome back, everyone, for another deep dive. And today, we're diving into something that's...
pretty cool.
Yeah, pretty cool. Very cool, actually. We're going to be looking at Iscar's Cut-V-Grip, multifunctional V-shape inserts.
Yeah.
I'm super excited about this one.
Me too.
I love new tooling,
Heck yeah.
and especially when it comes to turning operations. These things have really been turning heads.
Yeah. They're really shaking up the industry.
Yeah, for sure.
Mm-hmm.
And we're going to find out why. Now, for those who haven't heard of Iscar,
Right.
they've always been kind of at the forefront of innovation in the machining world.
Yeah. They're always coming out with some new technology.
Always pushing boundaries. So before we get too deep into the weeds here,
Right.
maybe you can just start with the basics. What exactly are these multifunctional V-shape inserts?
So basically, these inserts are like the Swiss Army knife of turning tools.
I like that.
They're specifically designed for external bidirectional turning,
Okay.
which is a pretty big deal in machining these days.
Yeah, I mean, I know what turning is, obviously.
Sure.
But what exactly is this, like, bidirectional aspect?
Okay, so think about it this way. Typically, when you're turning, you're cutting in one direction, right?
Right.
But these inserts are designed to cut smoothly in both directions.
So you don't have to keep switching tools?
Exactly. No more stopping, repositioning, switching inserts. It's a huge time saver.
That's got to be a huge plus for machinists, I mean.
Oh, absolutely. It really streamlines the whole process.
Less downtime, more efficiency, yeah.
Exactly.
So you said Swiss Army knife. What else can these things do besides just turning?
Oh, that's the really cool part. So not only can they handle turning, but also profiling and chamfering.
Whoa.
Yeah. It's like having 3 tools in one.
3 tools in one.
And on top of that, they're good for both front-endy back turning.
Okay, hold on. That's a lot to unpack.
It is.
I mean, it sounds super versatile, but
Yeah.
can you maybe give us a real-world example of how this would work, say, in a machine shop?
Sure. So imagine you're working on a complex part. Maybe it's for aerospace or something.
Yep.
You need to do some turning, a bit of profiling, maybe chamfer an edge or two, and you need to do all of this on both the front and back faces of the part.
Right.
Traditionally, you'd be swapping tools like crazy.
Yeah, constantly switching back and forth.
Exactly. But with these V-shape inserts, you could theoretically do all of that with a single tool.
Wow.
You just keep on cutting, moving from one operation to the next, all in a single setup. It's a total game changer in terms of efficiency and productivity.
Now, that is impressive. And I got to imagine that all this back and forth cutting with traditional tools, that can't be good for the workpiece, right?
You're absolutely right. All that stopping and starting can introduce inconsistencies and even damage the workpiece in some cases. But with bidirectional turning, you get a smoother, more continuous cut, which leads to higher quality finishes and more precise results.
Yeah, that makes a lot of sense. So less downtime, smoother cuts, more precision. I mean, these things really seem to have it all. But what about chip control? I'm thinking all this machining is going to generate a lot of chips. How do these inserts handle that?
Great question. Iscar has actually designed a unique chip former specifically for these inserts.
Okay.
And it's all about creating small, manageable chips during machining.
Right, so they don't clog up the works.
Exactly. This is super important for safety, You don't want chips building up and creating a hazard.
For sure.
But it's also really good for the cutting process, too. Smaller chips clear out easier, which means less friction, smoother cuts, and it actually reduces wear and tear on the tool itself.
Oh, so it's safer, more efficient, and extends tool life.
Pretty much, yeah. They've really thought of everything.
All right, now for the real mind-blowing part, these V-shapes, they can actually reach those super narrow, tricky areas that traditional V-type inserts just can't, right?
That's right. And that's a game changer for a lot of industries.
Like, why is that such a big deal? I mean, who really needs to machine in those tiny spaces?
Well, think about things like aerospace components or medical devices, intricate designs with tiny little features.
Right.
Reaching those areas with precision has always been a huge challenge.
Gotcha.
But with these new inserts, the possibilities are pretty much endless.
So you could be making parts that are, like way more complex and detailed than ever before?
Exactly. It's really pushing the boundaries of what's possible in machining.
Wow, that's pretty amazing.
It is.
And to top it all off, these inserts are made with that, grade IC808?
Yep, that's right.
Which is known for its durability, right?
Exactly. It's a really tough material. It can withstand a lot of heat and pressure, which means the inserts last longer and they perform really well even under demanding conditions.
Okay, so let's sum this up. We've got inserts that can handle multiple operations, cut smoothly in both directions, improve chip control, they last longer, and die. They can reach those super tight spots that were basically off limits before.
Yeah, it's a pretty impressive package.
It really is. Iscar has knocked it out of the park with this one. But I gotta ask, where do you see this kind of technology heading in the future?
That's a good question. I mean, it really makes you wonder, right? Will we start seeing even more intricate designs?
I think so.
More complex parts being made because now we have the tools to do it.
Right.
It's exciting to think about what the future holds for machining with this kind of innovation happening.
I know. All right, well, I want to thank you for breaking all of this down for us today.
No problem. Happy to be here.
This has been another fascinating deep dive. And until next time, happy machining.
Happy machining!